All right, guys, so part 4 is asking, does memory training help? And again, this is hypothesis tests for MUDIF. So the question says, does memory training help? Suppose that 32 seniors are randomly selected, good to know, to try 2 different memory strategies. They were given a list of words, then given 3 minutes to memorize as many words as possible just by rereading the words. So it sounds like that was their first memory strategy, just rereading the words. They recorded as many words as they could remember. Then they were given a different list of words and 3 minutes to memorizing them using a memorization strategy, so something different than just rereading the words. They recorded, again, as many words as they could remember. So each student calculated the difference in the number of words that they were able to remember. So they took strategy 2 minus strategy 1. So if the memorization strategy improved, I'm already thinking of this, if it improved their ability to remember words, then this will be a positive difference. If the memorization strategy made them worse, this will be a negative difference. The mean of those differences. So literally for each student, let's say, student number 1, for the first strategy, they remembered, 15 words. And for the second, not X bar, just X2. For the second strategy, they remembered 30 words. The difference then between them would be 30 minus 15, or 15. Now, these are the values that are going to be averaged. Each student is calculating their own difference, and they're going to average those out. Once they did that, they found the mean difference, the sample mean difference, X bar sub diff, was equal to 1.5. So it wasn't a huge difference in average words remembered, but then the standard deviation differences, S sub diff, was 2.7 words. Okay. So that's going to be important for us. We're going to need that statistic. All right. It says, do these data give convincing evidence that strategy 2 improves memory at the alpha equal to 0.05 significance level? Okay. Give convincing evidence. That's the hint. We're doing a hypothesis test. And my claim, or what I'm trying to test, is that strategy 2 improves memory so that the mean difference, let's see, if it improves, and then this difference will be positive, is greater than 0, okay? At the alpha equals 0.05. So I can just go ahead and fill in my significance level here. All right, let's write what our parameter is. Again, excuse me, we're looking at a difference, a true mean difference. True mean difference. So we want mu sub diff. And the way to tell whether or not we are dealing with a difference in means from 2 different samples or a mean difference from just 1 sample is to think about whether the data is connected. In this case, each student has a strategy 1 value and a strategy 2 value. So this is really just 1 sample. It's this sample of their differences. This is definitely matched or paired data. Okay, so mu diff is the true mean difference in words remembered. We weren't quite lucky enough that they gave that to us word for word, but we can pull that. It's the mean of differences, and we again talked about the difference in the number of words that they remembered. So true mean difference in words remembered, and it told us they were doing strategy 1 minus, oh, that's not right at all. They did strategy 2 minus strategy 1. Okay, so then our statistic is this X bar sub diff, and we were lucky enough that we do not have to calculate that on our own. It was given to us. It was 1.5. All right, and then our hypotheses are, our null hypothesis is going to be that mu sub diff or mu d, I don't really care which notation that you use, is equal to 0. And again, this is always going to be the case for our null hypothesis. We're always going to assume that the difference is 0, that there is no difference between the 2 groups. That looks a little bit different than it did for a difference in 2 means, like that we have here, right? We had mu1 minus mu2 is equal to 0. Here we take those differences and then average those, but we think that average difference is still equal to 0. The groups are not actually different. And then our alternative hypothesis, would be that strategy 2 improves the memory. So strategy 2 minus strategy 1, if strategy 2 improves it, they should have more words. So this should be a positive difference. So again, we're going to say mu diff is greater than 0 words. Okay, so I think I have all of my state things that I need. Let's do the name of the procedure. Again, this is just a one sample because it's paired data. One sample T, this time it's a test for mu diff. Okay, it's important that you get this part right, whether it's mu sub diff or whether it's mu1 minus mu2. So let's check the conditions. All right, first, we do have randomly selected seniors, right? It says the 32 seniors were randomly selected, so my random condition is met. Randomly selected seniors. Okay. My second condition, since I have a random sample, I have to check the 10% condition. N is equal to 32 is less than 1/10 of all seniors. I think that's reasonable to assume. There are more than 320 seniors. And then the third condition is the normal condition. So I have 3 ways to calculate it or to check it again. I don't know anything about the population distribution, so that first way is not what we're going to go with. The second way is that N has to be greater than or equal to 30, and that's true for us. N equals 32. So the CLT applies. And that's good because we don't have the sample data this time. We would not be able to check whether the sample distribution showed a strong skew or outliers. So it has to be one of the first two, and luckily it is the second one. Okay, so in the next video, I'm going to show you how to use StatDisk, going to analysis, but this time hypothesis testing and a mean for one sample in order to run this test.